soar, use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, hello everyone. Welcome to the next episode of NEAR Office Hours. Today we have Matthew from OpenGradient. Interestingly, a while ago, Illia and I were in a little room with a whiteboard brainstorming on what user-owned AI should look like. And a lot of things that OpenGradient are doing is something we had on that whiteboard. So it's going to be an exciting conversation. So Matthew, do you want to take a couple words about yourself and what OpenGradient is doing?
Yeah, absolutely. First of all, I wanted to thank you and the NEAR team for putting this together. Very excited to be here. Nice to meet everyone. My name is Matthew, one of the co-founders of OpenGradient. So OpenGradient is an open intelligence network, and we're building a decentralized platform for hosting models, secure inference, agentic reasoning, and application deployment. So we have full stack of a variety of different products that I can get into later. But from a high level, we're excited to be building this decentralized secure infrastructure that can help not just make AI more accessible from anyone, leaning into the whole Web3 and blockchain ethos, but also build solutions that can allow blockchain developers to easily integrate AI or ML into their applications and build more optimized or more intelligent applications. So yeah, super excited to be here. Personally, for me, my background was in ECE. I'd done stints of ML research as well, and back when I was in school. Had some experience doing things like data science at NASA, building ML models at Google, engineering at Facebook, and I spent most of my professional career as a research engineer at 2 Sigma, which is a quant fund based in New York, where I built quantitative models as well as a lot of modeling infrastructure for an equity options market making desk. And yeah, I met Adam, my co-founder in New York, who had spent 6 to 7 years at Palantir, where he was a tech lead on AIP, which is their AI platforms. And he led notably the development efforts on Palantir's patented AI agent execution framework, which I found to be very, very fascinating. So yeah, and we've been building since we met at the end of 2023. And we're very excited to be continuing to show the world what OpenGradient is about.
Yeah. So OpenGradient, it consists of several things, right? So I guess we can unpack each of them separately. Or maybe we can talk about how they all fit together. But so one of them is the Model Hub, which is my understanding is it's a decentralized take on Hugging Face, right? And couple of things that are interesting here. One is what is the infrastructure behind the Model Hub? What is it built upon? And what is let's begin with the more why, right? So what's wrong with Hugging Face? Why do we need a decentralized Model Hub? And then what is powering it behind the scenes?
Mm-hmm. Yeah, I mean, I would definitely not say that anything's wrong with Hugging Face. It's a product that has found tremendous product market fit. And they've built a very, very rich suite of different tools and technologies that I think many tech companies today are now kind of relying on. I would say, what the OpenGradient AI Model Hub aims to do is to kind of fit that niche within the Web3 space and make it easy for Web3 application developers to integrate AI and ML into their applications. So what that actually means in practice is we have a lot of these out-of-the-box solutions that come with, as an example, running AI models in TEEs, generating zkML proofs for different model inferences that are necessary for a lot of applications building the blockchain space. So it's kind of this taking Hugging Face and what they've already built and building kind of a version of that is extremely well tailored towards a Web3 audience. And on top of that, of course, leaning into the ethos of decentralization from the architecture. You can think about the model storage that we have as a fork of IPFS. So anyone can run a storage node and be able to contribute to that network. And the blockchain infrastructure that I can get into down the line essentially interacts with this storage layer. And we've also created some abstractions that are available on the AI Model Hub as an example, running, inference through our playground, or if you want to use our SDK, you can interact with these models that are stored in our decentralized file store, utilizing our blockchain infra without having to deal with the whole blockchain complexities. You don't need to build your own smart contract. You don't need to kind of like access these nodes. You can just, from a very familiar developer kind of CLI or Python environment, be able to run all these things.
Yeah. And I went to the model hub. I saw there's a couple of models, something along the lines of price prediction. So I see your background from the past life is contributing to the
so a little bit of kind of context on that. I think back when I was at 2 Sigma, there was this term that we threw around a lot that we called like research velocity. And the entire idea behind that term is that models, especially things for like trading or finance, a lot of the time individual models just aren't going to be that good, right? Models, their half-lives just aren't very long. Sometimes they overfit on data. Sometimes your alpha gets crowded out. Sometimes the model loses its edge. So a lot of the times we have to build technologies that, as an example, do model ensembles that help reduce, prediction, kind of loss and error rate of the models. Also, on top of that, people are constantly building new models and iterating on them. So I guess like from a high level, you can think about the hub as a tool that allows people to, take other models that people have developed and rapidly iterate on them. And that's just because we want to give people the power to kind of continue to iterate and build better models over time. There's not going to be one model, in our opinion, that trumps everything. We kind of just built some sample models, but we're very excited to kind of see, ML developers and Web3 developers alike kind of build these technologies that will gradually improve and the quality will get better over time.
And you mentioned a couple of times by now the blockchain. So is it just like a set of connectors of the model hub to the blockchain, or is there anything specific that like so it mentions here that it enables performant AI. So I wonder what is the performant side of it.
Yeah, so typically in regular blockchains, which are replicated state machines, every single node re-executes every single transaction, and then they attest to, hey, is this the current state of the blockchain? Consensus is reached, and we move on to the next block of transactions. What we've done here is we've kind of fundamentally reimagined what kind of a blockchain, what blockchain architecture might look like. And we've kind of leaned into this idea of node specialization, or we call it like heterogeneous compute, which is creating different types of clusters of nodes that do different things. So we have, as an example, regular blockchain nodes that execute stateful EVM transactions. We have a new set of nodes called inference nodes that compute, or powerful GPUs or TEs designed to compute inference and generate any associated proofs or attestations. And we also have data access nodes, which are TEs that use TLS certificates for secure data access. And then the inference nodes then they kind of interface with our storage nodes, which is the model store. So what happens when someone wants to run, let's say, a simple inference, is that transaction is submitted, the sequencer sequences the transaction, and it goes into this specialized kind of simulation pipeline in which the inference piece is load balanced to the cluster of inference nodes that then computes the inference and generates any associated proofs, sends that back. And we embed in the state transition function the validation of those proofs and attestations. And so this is kind of, I guess you can think about it like it's done off chain, except these inference nodes are all registered on our network as well and participate in cryptoeconomic security via an eigenlayer AVS. So if they generate garbage proofs, they can get slashed. And on top of that, the validation of these proofs are natively embedded in the state transition function as well. So this allows anyone who wants to validate, inference transactions on our network, as an example, to run a node, and all the zkML or TE enabled inference proofs will go through their node, and they can ensure that they get trust minimized access to AI.
So I have a couple of questions about inference, but before we jump into inference, I guess there is a more fundamental question. So this the nodes you mentioned, is it a brand new layer one, or is it built on top of existing infrastructure, and it's only the inference nodes that are unique to OpenGradient?
Yeah, so technically, using, I guess, like mainstream blockchain kind of terminology and semantic definitions, we would be classified as a layer two because we use NEAR.AI. So all the proofs and attestations, in addition to the block data, are stored in that blob space, and we have like a sequencer. But we kind of see ourselves as kind of the sovereign layer where we want to kind of have native AI-driven applications built on top of us. And when I say AI-driven applications, this can come in many ways, shapes, and forms, which I can elaborate, later when we talk about use cases.
Yeah. So for inference, right? You mentioned that it's running. You mentioned two things. You mentioned trusted execution environments, and you mentioned zkML. So I'm curious, right? So my prompt goes into the system, right? We need to get the response. What happens to the prompt from there? Why is it multiple nodes? Why not a single one, right? And what is the nature of the proof that ends up on chain and is validated?
Yeah, so right now we support, I guess I can maybe talk about what the user flow is initially. So directly, within the kind of precompiled libraries, there are options for you to choose from. Either we have pessimistic zkML, which is a zkML proof is generated on every single inference. We have optimistic zkML, which is where we only run inference, but we don't generate the proof to save on costs. And users can then submit challenges within a time window to see that proof be generated, and we can decide to arbitrate if that proof is valid, challenger loses a stake, vice versa, the inference node gets slashed. And then we also have TEE attestations. And right now we have two different types of TEEs and attestations on our network. One is Nitro enclaves, and the other one is like H100s. They're confidential compute enclaves that were recently onboarding. So that's kind of like, I guess, the different levels of security that we have, and we allow kind of users to choose from what type of security they want for their inference directly from the function call. And kind of directly answering your question of why we have multiple nodes and multiple kind of like security solutions for this, it is ultimately allowing the users to be or developers in this case, to be very, very flexible with what best suits their intended use case. As an example, if they want to inference just a small, like a gradient boosted tree model or regression model, zkML works just fine and can, be quite powerful for that, right? Whereas for things like LLM inference, zkML is just not a particularly practical solution due to compute costs, and we want to rely on TEs. And the multiple node situation comes in where we can have many different models cached on different nodes. So the load balancer embedded directly in the sequencer, pings these nodes every couple seconds and is able to say, hey, if I want to route a model inference for, let's say, Llama, I know which nodes are capable of producing which kind of proofs, and I also know which nodes have that model cached. So this is purely just for performance optimization.
I see, but a particular prompt will go to a single node, or will it go to multiple?
It would go to a single node.
I see. And there are two things. So when it comes to TEs help you with two things. One is that you can actually get a proof that the output you're looking at is in fact a response of a model to your prompt, right? Like you can go to the GitHub, then load the virtual machine that is used, compute the whatever the hashes, and get the quote. But it also gives you private inference. zkML only gives you the former, right? So if I choose to use zkML, my prompt will be visible to the node, right?
So for zkML, you can actually, so we use Ezekiel, their library, and you can actually choose what you want to hide and choose what you want to show. There actually are different visibility settings. You can either choose to hide the model and make the inputs and outputs visible, or you can choose to hide, let's say, like some like output or input instead. You can actually, there is some variability there. I think right now, currently, we're focused on, we're not focused on privacy preserving compute just yet. Kind of one of the benefits that we see of putting this on the blockchain to begin with is the verifiability aspect. But we are kind of working on some kind of privacy preserving solutions involving both zkML and TEs for use cases in which someone develops a valuable model, or someone wants to run compute on some private data and they don't want certain parts of it to be exposed to the world. But I think that's definitely more of an ad hoc kind of use case that we have. A lot of our kind of existing clients are kind of building, utilizing us as opposed to centralized solutions for that verifiability aspect.
And what are the primary use cases for verifiability?
Yeah, no, I'm glad you asked. We kind of put out this write up on all the different use cases that we have. I guess I can just maybe quickly walk through a couple of them. So the biggest use case I think that we're excited about is DeFi, and we think that for example, there are a lot of low hanging fruit like Uniswap, AMM fee optimization research that we had put out a while ago, where we can see that hey, if we use ML models to compute dynamic fees, we can reduce net and permanent loss for LPs and increase fee collection for LPs by up to 18%. So this is kind of preventing or mitigating effects of LVR. Things such as risk models to help improve, yield aggregators, as well as vault protocols as risk-adjusted returns, as well as kind of risk models for lending protocols to optimize collateralized LTV ratios in these pools. So outside of DeFi, there's also, reputation models for deep-in networks. So we can, outline a couple different features like, liveness, uptime, things like that. And we allow these models to dynamically score, the performance of different minor nodes on deep-in networks. And actually, if you check our model hub, Filecoin, we have a couple Filecoins as models on our model hub. And this basically allows us to say, hey, you want to be a good deep-in node, you should get a good reputation score, and we'll allocate rewards, proportionally to your reputation score. We also have some interesting use cases around using ML models to price different prediction markets, things like that. I can maybe dive into, some of these if you're curious, but a lot of these kind of use cases are high impact kind of use cases where if the model inference goes wrong and the AI or ML workflow is running correctly, it could lead to kind of implications with users' funds. And as a result, we want to ensure that everything is end-to-end, verifiable, and that users get this guarantee around the compute that we provide.
Yeah. And what is so as a user, because there's a model hub, I can download the model, right? The models are public, right? So what is what would be what are the trade-offs between running it on top of OpenGradient as opposed to, for example, just running it locally on my own machine?
Yeah, so I mean, this kind of leans into the whole, I would say two things. Number one is verifiability, right? People want to ensure that the quality of the model is good. They might, even if they can guarantee the compute is done correctly, they want to be able to maybe download the model and run their own simulations or audit, make sure that the model looks reasonable. So similar to like Kaggle or Hugging Face, we provide a big platform that allows people to go and download and access these models as well. And the second one is kind of like model versioning, which allows developers to constantly iterate on these models, allows people to come, upload their own versions of these models. So it kind of fosters this kind of open source community around development of these models. And on top of that, people can build workflows that involve, let's say, models I've developed, other people have developed prediction models as well. We can kind of aggregate them and do like a model stacking, ensemble approach, and ultimately create a workflow that is even more, or that leads to more accurate forecasts than just a singular model.
Yeah. And right now, this is primarily used. Has there been any work towards autonomous agents that use those models to take action on chain, or is it still primarily operated by humans?
Yeah, so that's actually one of the things I'm very bullish about, and I had talked to a couple of folks from NEAR about this as well, which is I kind of see AI agents, and I would love to hear your opinion on this as well. I think they're currently in a stage where initially it's kind of a mimetic, right? These AI agents can put out tweets on Twitter. It's just interesting. And the next step for agents is they can gradually replace what humans can do. So I don't need to go and place a trade on Uniswap. If I can just tell an agent, hey, can you swap out 1 ETH for USDC on Uniswap for me? This does that for me. And I think the next step for agents in this case is to be able to allow agents to complete complex tasks better than humans. As an example, how do I manage a portfolio, right? How do I take in these spot and these volatility forecasts and perform Markowitz-style mean variance analysis to optimize my portfolio allocations and holdings, right? These are all kind of complex tasks that a simple LLM might struggle to kind of do effectively. And as a result, we kind of want to build these powerful AI and ML workflows that allows agents to leverage them to do cooler things, right? If you tell an agent what token, or if you tell an LLM, if asking what token should I buy to maximize my risk-adjusted returns, it'll probably say something generic like Bitcoin, or like, I don't want to provide financial advice. But in this case, these AI agents will then be able to leverage these ML workflows and models we've built to kind of do all these things, which is now something we're diving into. And we're actually putting out something, or releasing an agent with Double Up, which is this GameFi / GambleFi protocol on Sui. We're building this AI agent that leverages our Sui spot forecasting model to set kind of money lines on their protocol and allows users to bet against it. So that's going to be our initial kind of foray into the agent space. And we're kind of talking to some other AI agent protocols and partners like Exponent AI, as an example, on how they can integrate our ML models into their agents to help users do bigger, better, cooler things.
Yeah, that sounds pretty cool. We have this toy example called Shield GPT, where people can show their meme coins to a model, to a system that is powered by I don't remember which model, but it's not particularly resilient. That's exactly the point of the name, right? If you show well enough, it will get convinced and it will buy it. And it's the performance of its portfolio was suboptimal, to say the least, right? So in this case, I think it's an interesting. If the models, so effectively, it's interesting how far we are from the state where there is a AI system sufficiently sophisticated that people cannot take advantage of it, right? Because on the market you play against others, right? If people can take advantage of your system, they will, right? So once the model can be sufficiently reliable that people cannot take advantage of it easily, or like ensemble of models.
Mm-hmm. Yeah, I think in this case, like as an example, you could build in a simple like a market risk or market forecasting model into Shield GPT. So as an example, if you're bullish on the crypto market at large, like it's likely that a lot of these meme coins will trade as levered beta to the market. And, you can, as an example, say, hey, if I am underexposed to the market, I can buy some more meme coins. If I'm overexposed, I can opt to be more risk averse in buying these tokens being shilled to the agent. I can dive deeper into these many like kind of quant finance upgrades that the agent could benefit from, but I'm particularly excited about kind of these more advanced agents that can leverage these technologies. And it's kind of like what we're building towards at OpenGradient.
So on the model hub, what are the incentives for people to publish good models? Do they is there an incentive structure, or is it mostly just a place for people to share for free?
Yeah. So we're kicking off a hackathon kind of later this month as well. So initially it's going to be kind of like bootstrapped by, hey, if you're a data scientist and you want to earn some cash prizes, come and build some cool models on top of us. But I think down the line we want to leverage both potential token incentives as well as kind of just like create an organic community that is kickstarted by application and protocol developers wanting to benefit each other and the ecosystem at large to kind of contribute to these models. And what I say by that is, practically speaking, an AMM might say, hey, we want to put out this new model that we're working on that does dynamic fee optimization. Someone else might be able to take that model and also put out a new one to not just better their protocol, but to kind of advance the space from a research standpoint overall. And yeah, a lot of it will be, both kind of inorganic incentives as well as, organic growth from kind of just like research mindshare.
Mm-hmm. Yeah. Going back to the blockchain part of things. So you mentioned that it's running its own sovereign chain. So I'm curious if it's if there exists some consensus algorithm that it's using, or if it's a single sequencer, and if there is in either case, what is the incentive structure there for those entities to do their work properly? Is there is there staking, or are they elected in a way?
Yeah, so currently we're a single sequencer. We're kind of like working off of Celestia's role kit framework as of right now, and we're kind of working with them. They kind of have a lot of initiatives to essentially down the line move into kind of like a shared sequencer kind of approach. But right now it is a sequencer, and when it comes to incentives for the inference nodes, as an example, or data access nodes to do their work faithfully. So these nodes, as I mentioned, are registered nodes on the network, and they earn a portion of the inference transaction fees for doing compute. So I guess for them, it is wanting to do good work in order to get monetarily rewarded, and also avoiding doing any bad work as to not get slashed by the eigenlayer AVS because they have to stake some tokens to participate in the network.
And the same for data nodes. They get like a fee from the inference.
Yeah, I think like we're still kind of deciding on what the right amount of stake is for these different types of nodes. Like it is likely that for these data access nodes, the stake will be lower. But yes, for these nodes to participate, they will have to participate in the AVS.
Yeah. And there's another component called Neuroml. So is Neuroml just a way for you to invoke those inference endpoints from Solidity, or is there more to the library?
Yeah, so that's definitely a part of it. But I think we realize that building AR ML driven workflows is a lot of the time not just about inference. I mean, for like LLMs, like perhaps so, but a lot of the time you might need to pre-process data, like normalize or standardize features. You might need to, if you want to run some simple statistical tests, like co-integration tests, or run simple regressions, a lot of the time, like, you want these tools, and building them in Solidity is just, kind of clunky, not particularly easy to do. And for us to, incentivize people to kind of, or to help people build these AI ML workflows in their smart contracts, these tools are necessary for them to kind of build with. And that, includes inference, but also, all these things that I spoke about.
Yep. And if I do any of those, like let's say I'm doing data processing, right, from using this Solidity library, will the data processing happen on chain, or is it also going to be sent to some other kind of node on the network?
Yeah, no, that's a great question. So right now we use kind of like a mixture of both. So for things like inference, I mentioned, we're kind of sending that over to these cluster of inference nodes. For things such as data preprocessing, or if it's like more light work, we're actually going to embed it directly within kind of like the blockchain nodes itself, because it's not a big workload. So there is a mixture of both, just depending on kind of how heavy the compute is.
Mm-hmm. I see. But if like let's say I have a massive data set I want to pre-process, I will just use the inference. So there's an API for me to like custom workload to inference nodes, or is it more rigid than that?
It's handled behind the background. I think right now that it is true. Like we have, like the main consideration is mostly just to move inference onto the inference nodes, and essentially the rest, including like processing data, that's going to be done kind of on the like within the blockchain nodes within like Go Ethereum. So that would be done in Golang. But we are thinking about creating a kind of like a special path for transactions. As an example, if you want to run like convex optimization, or if it's like you mentioned, maybe a huge data set, we don't obviously want to replicate that compute many times over. So that might be kind of like load balance to these specialized inference nodes as well. That's kind of currently still like in development. We don't have it live on our network as of right now. But I think it's also important to kind of consider the fact that a lot of our workloads are kind of more geared towards like inference, or running kind of statistical tests, and less so around training. So these workloads might be large, but it's not going to be kind of on the magnitude of what's necessary for training.
Yeah, awesome. Okay, so we're getting close to the end of this session. So I guess my last question is, what is sort of your overall vision of the future with the AI and the Web3 together, and what is the what's next exciting for OpenGradient?
Mhm. Yeah, I think a lot of the times I like to kind of use this mental experiment to kind of think about what might kind of lie in the future for Web3, and that is if you look at kind of existing Web3 apps, many of them kind of don't really leverage ARML at all. But if you look at Web2, I couldn't name a couple apps that don't use ARML in any capacity at all that I interact with on a daily basis. And I think for Web3 to really gain mass adoption and to be competitive with either TradFi or Web2, it is inevitable that a lot of these applications will integrate ARML to some extent to optimize kind of the features or the user experience or the liquidity provider experience. And so, my question is, okay, what's necessary for these applications to kind of utilize these technologies in a way that is easy and also secure? And to me, that's what kind of OpenGradient represents. We're kind of filling that gap that allows Web3 applications, whether you're DeFi or SocialFi, or whether you're building a pure AI application, to really like bridge that gap and be able to utilize secure and easy to use out of the box solutions that gets you to that next level, and also while fostering kind of this open source community around these exploring of new design spaces enabled uniquely in Web3 through this ARML kind of product that we have. So yeah, the vision is hopefully 5 years down the line, most applications are smarter, more intelligent, more optimized because they have access to this technology. And we will continue to build not just infrastructure, but also kind of showcase applications, continue pushing on research and building models that can help people eventually bridge that gap.
Yeah, exciting future ahead of us. Thank you, Matthew, for joining us today. And see you all guys on the next episode.
Awesome. Thank you so much for having me. Had a great conversation and really excited to kind of continue pushing on this. Thanks so much, Alex.